Hi, Professor Bob Young here again, and in this instructional video, we are going to work on quadratic application problems. And remember, quadratic form is ax squared plus bx plus c equals 0, where you usually get two answers. And as we've been solving these quadratic equations by completing the square, using the quadratic formula, factoring, and so forth. So we're going to look at three types of quadratic application problems: some geometry, Pythagorean theorem for right triangles, and a word problem involving height of a projected object. Now, as we go along here, when solving problems that lead to quadratic equations, we may get a solution that does not satisfy the physical constraints of the problem. For example, if x represents the width and the two solutions of the quadratic equation, let's say, come out -9 and +1, the value -9 must be rejected because you can't have a negative width of, let's say, some geometric figure as far as if you were building something. So what we call these type of problems or solutions are extraneous, extraneous solutions. You must throw them out if they don't make sense in this section. So a new word for you to remember. All right, so let's go ahead to example 1 here. We're going to solve a problem involving the volume of a box. So it says a piece of machinery is capable of producing rectangular sheets of metal such that the length is 3 times the width. Equal size squares measuring 5 inches on a side can be cut from the corners so that the resulting piece of metal can be shaped into an open box by folding up the flaps. And you've probably seen this, like when you buy holiday boxes, they'll give you ones where the flaps are fold up and all flat and stuff. And, you know, different packaging places will have boxes you can get and ship that way. But in this one, it says the specifications call for the volume of the box to be 1,435 cubic inches. What should the dimensions of the original piece of metal be? So remember some of our strategies for solving word problems. 1, make sure you read the problem, and sometimes you have to read it more than once to dissect it. All right, but we in this case must find the dimensions of the original piece. Draw a picture if you need to, you know, write things out and see if you can make it make sense. Now, in this case, and I'm going to go to my red here, we know that x is going to be the width, and it says the length is 3 times the width, so we're going to call the length 3x. Now, the box is going to be formed by cutting 5 plus 5 equals 10 inches from both the length and the width. So let's think about this for a second, and I'm going to use some other colors here. Let me use my green. So here's this pretty blue box here. We've got with dimensions of 3x by x. But we also want to have 5 inches corners that we can hold up so we can create the box. So on this first top length here, let's say that this is 5 and this is 5. So do you see that if we're going to be able to fold this box, we're going to have to go ahead and make a box where we have to subtract 5 from each length, so that new length will be 3x minus 10. So this box in here will be the folded part when we're done. And that's the picture over here in pretty blue. Let me take another color here. I'm going to take a violet. And on the width here, same thing. I mean, if this width out here is x, and we cut 5 from each part there, the new width will be x minus 10. So you can see now that when we have our box all folded and everything, we're going to have a dimension of height 5, width x minus 10, length 3x minus 10. So you have to kind of use your noodle on some of these and think about it, draw pictures, you know, read the information more than once. Now the formula for the volume of a box is V equals LWH, length times width times height. So we got our equation set up here. Now notice here also the dimensions of the box must be positive numbers, so the 3x minus 10 and the x minus 10 both must be greater than 0, which implies if you take each one of these parentheses and set them equal to 0 here, that x must be greater than 10/3 and x must be greater than 10. Now, since 10 is larger than 10/3, in order to meet both requirements there, because you can't have any negative values there once we start plugging things in, the next graphic will show that you must have x greater than 10 to satisfy this. Now, what we're going to do next is just go ahead and solve the problem. So it looks like we've got some FOILing to do here. So I'm going to go ahead and FOIL those binomials, and I'm going to do it quickly here. So we've got 3x squared. The outside's minus 30, the inside's minus 10x, will give us minus 40x plus 100 here. And then I'll multiply the 5 through last there. So I FOILed here first. And then I'm going to go ahead and distribute the 5. As you will see in this next graphic, it'll be all done and pretty. Because I'm trying to save time on these graphics here. I'm trying to cut these videos down, try to keep them under 15 minutes, as not to bore you too much. I know some of you might be saying it's too late, young. But anyway, distributing, here's what we get. 15x squared minus 200x plus 500 equals 1435. Now, get it equal to 0, bring the 1435 over here to get it in that nice quadratic form. So subtract 1435. And notice what they did here is they went ahead and they saw a common number that they could divide by to make the problem easier. So they saw that you could divide each term by 5, and of course 0 doesn't care what you divide him by, and there's your old multiplication property of equality. And you get a nicer thing here, which they factored, and they get the answers and so forth. Now, let's say you had trouble factoring this beast down here on the bottom. Remember, you can always use your quadratic formula. You could plug 3 in for A, negative 40 in for B, negative 187 for C. So things that are difficult to factor, the quadratic formula lends itself to get the 2 answers. It always works. All right, so factoring and solving, we get the 2 answers of negative 11/3 or positive 17. Now, of course, this negative 11/3 is the extraneous solution. It can't happen. You can't have negative dimensions of your box. So the correct answer is 17. And notice only 17 satisfies a restriction that x had to be greater than 10. So the dimensions of the original piece should be 17, which was x, times by 3 times 17, which is 51, because the length was 3 times that. Now, will this check and make sense? I think so. The length of the bottom of the box is 51 minus 2 times 5 is 41. The width is 17 minus 2 times 5 is 7, and the height is 5. So if you multiply the old length times width times height, you will get the 1435, and it will make perfect sense. So there was example 1 here. Now, the next few examples won't be quite as beastly as that, thank heavens. And some of you probably remember this from your old high school geometry classes, the Pythagorean theorem for right triangles. So remember that 2 sides that meet at the right angle are called the legs of the right triangle, and the long side opposite the right angle is called the hypotenuse. All right, so you've got a pretty picture there. A, and here comes the old formula I'm sure you remember and have nightmares from in high school. A squared plus B squared equals C squared. So in a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. All right, now let's say example 2 here. Eric finds a piece of property in the shape of a right triangle. He finds that the longer leg is 20 meters longer than twice the length of the shorter leg. The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular lot. So here's what we've got in this problem here. We've got a shorter leg of the right triangle, which we have to call something. We have a longer leg, which we have to call something. And then, of course, we have to call the hypotenuse something. Now, what I want you to think about for a second, pause this. I want you to see if you can set up all three of these sides of the right triangle in terms of x. And I'm going to give you some help here. I'm going to say that the shorter leg is going to be x meters. Now, I could sit here and go through them and through them and through them, but I want y'all to think about what the other ones will be. Now, I think in the graphic, they're not going to call it x, they're going to call it s. Now, I don't like s, okay, because it looks like a 5, but that's what they're going to call it. So maybe instead of x, I should say, scratch that, let's call it the shorter leg side s, as in snake. And you see if you can get the other two. Okay, here we go. Think about it. All right, so if s is the length of the shorter leg in meters, then 2s plus 20 is the length of a longer leg. It said 20 more than twice the shorter. Did y'all get that? And then the hypotenuse would be 10 more than the longer leg, so that's 2s plus 20 plus 10 is 2s plus 30. Now I'm taping this, and it's just starting to pour rain here at my house, so you'll hear all kinds of things as we're taping and stuff. I saw power going in and out. We haven't had a good rain in so long. This is great. We need it. All right, so now we're going to say a squared plus b squared equals c squared, and we're going to go ahead and plug in those three things. So s, 2s plus 20, and 2s plus 30. And notice it says be sure to substitute correctly here, because you want to make sure you get that hypotenuse correct. It really doesn't matter which one you put in for A and B, but you've got to have the long side correct. And then remember, whenever you square a binomial, it is a FOIL problem. So you have to be careful. Now, a lot of students will make the mistake of just squaring the 2s and squaring the 20, and they'll forget to do the O and the I. Okay, so be careful to do that. And then we will continue this graphic here. And notice they have gone ahead and FOILed it here. And again, I'm trying to save some time. So we're going to get our nice quadratic equations, and you guys could do this as you go through and see if you can get the answers and pause it in here too. All right, so the two answers again, and they factored it to get 50 or negative 10. Again, negative 10, the extraneous solution, throw it out. So your answers will be 50. 2 times 50 plus 20 is 120. And then 2 times 50 plus 30 is 130. And I think if you take the a squared plus b squared, you'll definitely get c squared down there in step 6. So that'll make perfect sense. And for the final example, we're going to look at a problem you may encounter in science class, possibly physics, astronomy, who knows what else here. But it says, if air resistance is neglected here, the height h in feet of an object projected directly upward from an initial height of s naught feet with an initial velocity of v sub naught feet is given by this equation, where t is the number of seconds after the object is projected. The coefficient of t squared and minus 16 is a constant based on the gravitational force of the Earth. So they just don't make these formulas up. They don't just pull them out of their you-know-wheres. I mean, these are actually things where gravity is affected on Earth. This constant varies on other surfaces, such as the moon and other planets. So we would have different formulas there. So in our next example here, if a projectile is shot vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height h in feet above the ground t seconds after projection is given by this equation. Now, actually, there's a mistake in the graphic here, so we're going to fix that real quick. This should be a negative 16t squared. Okay, because what this is going to be a picture of, and when we start graphing quadratic equations, they are going to be pictures of parabolas. So what's going to happen here is we're going to have this, let's say it's a rocket that's projected here, and it's going to have different heights at different times, as y'all can see, going along that curve until it hits the ground again. So this is what we're looking at here. So there's our formula. Now it says, after how many seconds will it be 50 feet above the ground? So we're going to go ahead in blue there and substitute 50 in for height. And I did fix the graphic here on that negative 16t squared. And remember, we want to get it in this quadratic form. We want to get it in ax squared plus bx plus c equals 0 form. And we want to make sure that a stays positive here. So I just went ahead and I brought everything over here to the left by adding 16t squared and subtracting 100t from both sides. And I don't know if y'all can hear the rain in the background there, but it is coming down. It's great. All right, so here is our equation. And notice that you can see, I think some of you might see here, now you could put 16 in for A and negative 100 in for B and 50 in for C, but they saw that you could divide everything by 2 and make it a little bit easier here because this one is not going to factor. All right, so this one, if you divide everything by 2, they went ahead and they plugged things into the quadratic formula here, and they said A equals 8, B is negative 50, and C is 25. All right, so plugging in, and we're doing what we've done in previous sections, here's what we get. Now, in this case, we need to know that the square root of 17, we actually have to use our calculator on this one. So if y'all have your calculators here, you will find that the square root of 1700 is about, I'll come over here on the side, is about equal to 41.2. So what we're going to get here when we use the formula, we're actually going to get a couple answers here. We're going to get 50 plus 41.2 over 16, and we're going to get 50 minus 41.2 over 16. And if you use your calculator, you're going to get these two answers of 0.55 approximately and approximately 5.7. So make sure you get those on your calculators. And it says in this case, both solutions are acceptable since the projectile reaches 50 feet twice, once on the way up and once on the way down. So remember, on a parabola here, if you were shooting this thing this direction, you know, it could have a height of 50 feet at this time, like 0.55 of seconds, and then when it gets way over here, it could be at 50 feet too. So just think about what we're dealing with. Now, part B says, how long will it take the projectile to return to the ground? So they can, once they give you some equation here and they give you parts, you can plug in. So we're going to let 0, since it says the projectile returns to the ground when the height will be 0 feet, so we're going to just plug 0 in for the height and solve. And notice our two answers here would be 0 and 6.25. So in this case, it would be the height, you know, when it first took off, it would, of course, be at height 0. And then when it landed over here, it would be at 6.25 feet. So there's a lot of applications you can do for quadratic equations. Now, can you think about the military using these applications with missiles and stuff? You want to make sure you're, you know, definitely launching to the right spot here. So in conclusion, it just says what I was telling you earlier, that 0 represents the time it was on the ground prior to being launched, and it will return in 6.25 seconds. So we're going to find all kinds of applications for quadratics as we continue the course. And this is concluding. Bob Young signing off.